Hi everyone. In this video we are looking at addition and subtraction of polynomials. So what is a polynomial? It's a combination of different terms that contain positive integer powers of the variables, like 3x squared plus 2 or 5y cubed plus 2x squared y plus 4. These terms have all positive integers. Name all parts of the polynomial. So we have four terms shown above. The coefficients are the number appearing in front of the variable, like 4, 2, and negative 3, and the constant is the number appearing by itself. And the variables are x. What is the degree of a polynomial? Give examples. The degree of a term is the power of the variable in that term. The degree of a polynomial is the degree of the term with the highest degree. 4x cubed is degree 3, or the third order. 2x squared is a degree 2. Negative 3x is a degree 1. And 1 has degree 0. Okay, so let's look at these examples in purple here. The first polynomial, the highest exponent is 3. So that's a degree 3, or a third order. In the second one, we have x to the fifth, but then the other term is x cubed y cubed. So that's actually a 3 plus 3, or degree 6. So in example 1, we're going to identify the coefficient, the constant, and the degree of each term and polynomial. So for part A, the coefficients are 1, negative 3, 4, and negative 5, which are in front of each variable. The constant is 7, and the degree, looking at it from left to right, is 5, 3, 2, 1, 0. The highest being 5, so it's a degree 5 polynomial. Part B, our coefficients are 1, negative 3, and 8. The constant is negative 12, the number all by itself. And the degree is 4, 5, 1, 0 in order. So because of the 3 and the 2 on the x and the y, it becomes a degree 5 polynomial. In example 2, we're identifying to see if the expressions are polynomials. We see that letter A and F are the only ones where they are, and B, C, D, and E are no, either because of a negative exponent or it's a radical. The powers all need to be positive integers. Okay, leading coefficient. The coefficient of the leading term of a polynomial in standard form. So standard form is when the polynomial is written in order of decreasing power. For instance, 5x cubed plus 2xy squared plus y minus 4. The leading coefficient would be 5. It's on the leading term. So example 3, we're going to write these in standard form and then identify the leading term and the leading coefficient. So for part A, it's negative 3x cubed plus 4x plus 7. The leading term is negative 3x cubed, and the leading coefficient is negative 3. We're going to do the same for B and C. We're going to put it in standard form and then identify the leading term and the leading coefficient. In example 4, we're going to simplify the following polynomials by collecting like terms and combining them. So the like terms are the terms that have the same variable and exponent on that variable. So I'll color code it here so you can see I'm arranging the like terms, and then I'm going to combine them. Now sometimes we have multiple variables in a term. They still need to have the same exponents on each of the corresponding variables in order for it to be a like term. Notice these last two here, the 2a cubed b minus 2a squared b, because the a's have different powers on them, I can't combine those, so I just have to leave them alone as they are. Okay, so let's take a look at the next one here. Example 5, we're going to add and simplify these polynomials. So I'm going to rewrite this. 3x squared minus 4x plus 7 plus 2x cubed minus 4x squared minus 6x plus 5. So I need to group the like terms together. So I have x squared terms, I have x terms, and I have constant terms. So I'll color code this again. The 2x cubed is all by itself. There's nothing else to add to it. I have two x squared terms, I have two x terms, and I have two constant terms. I can now combine these, simplify. Part B, we're going to do the same thing. I'm going to rewrite it. I'm going to identify the like terms and then group them and combine, simplify, and then try to write this in standard form so that y cubed, that's all by itself, I could put in front because that's the term with the highest degree exponent. Example 6, we're going to subtract this time. So we're going to subtract x cubed minus 3x squared plus 8x plus 2 from 4x squared plus 5x minus 9. So be careful how you write this. Once you rewrite it, you need to distribute that negative so it changes all the signs inside the parentheses. Now we are going to identify our like terms and group them together, and then we'll combine them, simplify, and write in standard form. I've color coded this again so you can see it a little better. We're going to do the same for part B. I'm just going to speed it up here a little bit more, but it's the same steps. Rewrite, distribute, group like terms, combine, simplify, write in standard form. So example 7, we're looking at 4 different shapes that have the areas that we're trying to write as a polygon. So we know area equals length times width. So basically I could take each individual square or rectangle and find the area of each and combine them. So I have 4 different shapes. That means I have 4 different terms. And notice we have like terms here in the middle. So I get the area equals x squared plus 2xy plus y squared. And we do the same for the other 3. Part C is a little bit unique because we're trying to find the area of this green region. So the easiest way to do this would be to find the area of the whole square, which would be y times y, and then subtract the white cutout portion, which is x times x. So this would be y squared minus x squared. Part D, I can break up the blue rectangle into 3 squares. So if I count them, there's 6 of them. So that would be 6a squared. Okay, we're done. Hope this makes sense. Now try your practice set. See you next time.